So any equation of this form, we call it as linear equation of higher order differential equation, right? So until now we were having these coefficients like an minus 1, an minus 2, an and a naught. Okay, these are all numbers until now we have taken. Okay, coefficients as numbers. Okay, but what happens if these coefficients are functions of x? Okay, so that too not an irregular function, that too a function of this kind of nth degree derivative means nth degree polynomial. Okay, so n power n minus 1, that means d power n minus 1 means coefficient must be x power n minus 1. So this is a particular kind of equation of this kind, x power n d power n y by dx square or dx power n. That means an I am replacing with variable quotient y x power n. Okay, similarly plus a n minus 1 I am replacing with x power n minus 1 d power n minus 1 y by dx power x power n minus 1 plus and so on, plus here x a2 is there, that I am replacing with x square d square y by dx square, plus a1 I am replacing with x dy by dx plus y1. Okay, which is equal to some function in x. Okay, so that means a small change where constants will be replaced with powers of x. Okay, so this equation is called Cauchy's equation. Okay, so how to solve this Cauchy's equation, that we need to go now. Okay, so previously if it is a variable quotient means we have many methods, type 1, type 2, type 3, correct? Like that we have studied up to 6 methods. Okay, now what we'll do is we don't have a direct method for this. Okay, for this kind of Cauchy's equation. So what he has done is we have to convert this into this type, that means equations with constant quotients, and we using that methods we are going to solve this. So that means indirectly what we are doing is convert this Cauchy's equation to coefficients as constants, and we are going to solve in the same methods which we have used previous 6 methods. Okay, so nothing new we are going to study. It is already we have studied in previous classes. Okay, with a small change. Okay, that means we have to take some assumptions or some substitutions we have to take, so that this equation, this Cauchy's equation, will convert to linear equation with constant coefficients. Okay, so what are those assumptions? Means here x dy by dx is equal to, I'll replace with this as dy. Okay, similarly x square d square y by dx square, this I'll replace with d into d minus 1 into y. Okay, until where you have to stop means select this power, subtract from minus 1 here. Okay, so 2 minus 1, 1 you'll get. So up to d minus 1 you have to do. Okay, similarly x cube d square, sorry, x cube d cube y by dx cube, which is equal to, until where you have to stop, d into d minus 1 into 3 minus 1, it is 2. So that means d minus 2 you have to stop into y. So like this it will continue. So for fourth order, fifth order, like that. Okay, so then we are going to replace these values in the given differential equations. And if you are changing derivatives, variable also will change, right? Okay, since you are changing uh, something related to derivatives, that means variable also should change. So that variable I am taking it as t is equal to log x, implies x value must be how much? If you take anti-log, you'll get e power t. Okay, so these are the assumptions we have to go through. Okay, so that means x dy by dx. If you see this, we have to substitute it as dy by dx. Similarly, x square d square y by dx square. So that means second order. Okay, can be replaced with d into d minus 1 into y. X cube d cube y by dx cube can be replaced with d into d minus 1 into d minus 2 into y. Similarly, it will continue. Okay, up to nth order. So based on our problem, we'll take the substitutions appropriately and we'll substitute in it. Okay, so since we are changing this, so we have to make changes in variables also. That's why we are taking t is equal to log x is equal to e power at, e power t. Okay, so let us see one problem so that we'll get a clarity on this. So here we are having x square d square y by dx square minus 3x into dy by dx plus 4y is equal to 1 plus x square, sorry, 1 plus x whole square. Okay, so now if I expand this, what happens? 1 square plus x square plus 2x. Okay, okay. Now take the assumptions. Take it as equation 1. What we do? D square, sorry, x square into d square y by dx square. This must be replaced with d into d minus 1 into y. Similarly, x into dy by dx, which is equal to dy. Similarly, only these two terms are there here. Okay, so I have to stop here only. Next, variable t must be replaced with log x. So since t variable is not there in our equation, we have to convert into x. X must be replaced with e power t. Okay, because we are taking anti-logs on both sides, so that log x is equal to t can also be written as x equal to e power t. Okay, so now you got x variable. So this x variable you can substitute in this place. Okay, so that all the equation will convert to unique form in terms of t. Okay, so therefore substitute these values in equation 1. From equation 1, what happens? D into d minus 1 into y. So that y I am taking common in all the terms, minus 3 into x dy by dx. This can be replaced with dy. So 3d you'll get plus 4 into y is equal to 1 plus x must be replaced with e power t. So e power t whole square can be written as e power 2t plus 2 into e power t. X must be replaced with e power t. So I have replaced with this. So now simplify this. How much you'll get? D into d, you'll get d square minus d minus 3d plus 4 into y is equal to 1 plus e power 2t plus 2 e power t. Implies if you simplify that equation again, you'll get d square minus 4d plus 4 into y is equal to how much? 1 plus e power 2t plus 2e power t. See now, this Cauchy's equation has converted into coefficients as constants. Now, this is the same method which we have to apply the previous things. Okay. So, right hand side exponential functions are there. That means it is related to type 1 equation. Okay. So, auxiliary equation is from here onwards regular problem like type 1, type 2, type 3 all are same. Auxiliary equation. Okay. So, what is auxiliary equation? M square minus 4m plus 4 is equal to 0 implies this can be written as m minus 2 whole square equal to 0 implies m1 equal to m2 is equal to plus 2. So when roots are repeated, so what will be the general solution? That means complementary solution.
C1 plus C2
C1
into
plus
X.
C2 X into
C1 plus C2x. So in the place of x, the variable must be t. So replace with t into e power 2t. Okay. So yc is equal to, again substitute back t value here. So if we substitute back t value, c1 plus c2x, sorry, t value is log x. Next, e power t whole square. E power t means x. It can be written as x square. So like this, you have to substitute back t value because your answer must be in terms of x. Because in the given question, the variable is in x. So we are substituting back whatever we have substituted here. Okay. Next, particular solution we need to do. So yp is equal to what happens? 1 plus e power 2t plus 2e power t divided by d square plus 4d, sorry, minus 4d plus 4. Okay, so this must be equal to yp is equal to e power 0t divided by d square minus 4d plus 4 plus e power 2t divided by d square minus 4d plus 4 plus 2e power t divided by d square minus 4d plus 4. Now apply type 1 method for each term. Yp is equal to, what will be the solution? 1 divided by, substitute 0 in the place of d. So you'll get 1 by 4 plus e power 2t divided by, if you substitute t in the denominator, since 2 is a root for the denominator, so it will become 0. So what happens when denominator gets 0 in type 1?
Differentiate
Differentiate and
into T.
into T.
yes, so we have to multiply with the t, you'll get 2d, sorry, 2d minus 4. Correct. Next, again if you substitute 2 here, what happens? Again you are
Again
getting
0.
0. Yes.
0.
Then what we need to do?
Again
T
multiply
square.
T.
Again multiply t, that means it will become t square by 2.
Differentiate.
So if you differentiate 2d minus 4, you'll get 2. So plus 2 e power t divided by 1 minus 4 plus 4. So therefore yp is equal to 1 by 4 plus t square e power 2t divided by 2 plus 2 e power t divided by 1 you'll get. Okay. So yp is equal to, if you take LCM for this, you'll get 4. Okay. 1 plus t square. T square means log x whole square. Next, e power 2t. E power 2t means x square plus 2 into e power t. So if you take LCM here, what happens? 2 into, right? This is,
2 in
so 2 into, here 4 into 2. So you'll get 8. E power t means x. So finally, yp is equal to 2x square log x whole square, okay, plus 8x plus 1 divided by 4. Therefore, general solution is y is equal to yc plus yp. Therefore, y is equal to yc. Yc is c1 plus c2 log x into x square. Next plus 2x square log x whole square plus 8x plus 1 divided by 4. Fine. So in this way you'll find the answer, and we got the solution in terms of x only finally. So just go through it once again from starting onwards. I'll give 1 minute for each slide so that you can go through it. If you get any doubts, let me know. Is it fine? We'll go for next one. Or any doubts here?
Yes, sir.
Yes, sir.
So again check with this problem. So here we are having x into d square y by dx square minus 2y divided by x plus equal to x plus 1 by x square will get. But if you observe this problem carefully, it is not in Cauchy's equation. How will you come to know? Yes, how will you come to know whether it is Cauchy's equation or not? Observe the previous question and this question once. So see this question and what is the difference between this question and this question.
dy by dx is not here.
Okay, no problem na. dy by
X
dx.
square.
Yes, power. Okay, so whenever you are having second derivative here, okay, coefficient must also be of degree 2. Then only we can say it as Cauchy's equation. Clear? So we have to observe the coefficients of higher order derivative. Okay, here the order is 2. So x degree must be also 2. Then only we can apply this method. Otherwise it is not possible to apply this. So for this what we need to do is multiply with x on both sides. Multiply x on both sides. So I'll get how much? X square d square y by dx square. Okay, minus if you multiply with x, you'll get 2y is equal to multiply with x, you'll get x square plus here 1x get cancelled, 1 by x will be remain. Okay, now apply substitutions. X square d square y by dx square must be replaced with d into d minus 1 into y. Okay, only one term is there having derivative here, only one term. So t is equal to log x implies x is equal to e power t. So now apply these substitutions in this problem and get it. So d into d minus 1 minus 2 into y is equal to x square. X square means e power 2t plus 1 by e power t. So multiply it inside. What happens? D square minus d minus 2 into y is equal to e power 2t plus 1 by e power t can be written as e power minus t. Shall I? So now we have overall equation like this: d square minus d minus 2 into y is equal to e power 2t plus e power minus t. So therefore auxiliary equation is how much? M square minus m minus 2 equal to 0 implies m is equal to, apply the formula to get the answer, minus of minus you'll get plus 1 plus or minus this can be written as root of b square minus 4ac. So b square means 1 minus 4 into 2. Is how much you'll get? 1 plus or minus root of 1 minus minus of minus you'll get
Root
plus
9.
plus 8. Okay, divided by 2. So this one is equal to 1 plus or minus root 9 divided by 2. Root 9 is
3.
3.
3.
Correct. So m is equal to 1 plus or minus 3 divided by 2. Implies the answer is m1 is equal to 1 plus 3. 4 by 2 means 2. Similarly, m2 is equal to 1 minus 3. That means minus 2 divided by 1. So you'll get minus 1. Okay, minus 2 divided by 2, you'll get minus 1. So therefore, we got distinct solutions. So when you get distinct solutions, solution is yc is equal to
C1 e raised to 2x plus C2 e raised to minus x.
is c1 e raised to 2t plus c2 e raised to minus 1t. Now replace with x. So c1 e power 2t means x square. So I'll get x square plus c2 x inverse. Okay, x inverse means 1 by x. That's it. So yc we got. We'll write yp is equal to e power 2t plus e power minus t divided by d square minus d minus 2. Okay. Now I will split this into like this. Yp is equal to e power 2t divided by d square minus d minus 2 plus e power minus t divided by d square minus d minus 2. So therefore yp is equal to 2 and minus 1 are the roots for denominator. Okay. So if we substitute it directly, you'll get 0. So what we need to do? Multiply t. So t into e power 2t divided by substitute, differentiate in the denominator. 2d minus 1 plus t into e power minus t divided by 2d minus 1. Yp is equal to t into e power 2t divided by substitute 2 in the place of d. 4 minus 1 it is 3 plus t e power minus t divided by substitute minus 1. You will get minus 3. So therefore you can take 3 as LCM, take t common, e power 2t minus e power minus t. So yp is equal to, write it in terms of x. So I'll get log x into e power 2t can be written as how much?
X square.
X square.
You get x square minus x power minus 1 whole divided by 3. Okay, so therefore general solution y is equal to yc plus yp. Therefore y is equal to yc. Yc is c1 x square plus c2 x power minus 1 plus x square minus x inverse divided by 3 log x. Okay, so this much is the general solution for the given problem. Let's go through it once. Let me know if you have any doubts. Just take a minute for each slide so that if you have any doubts, let me know from starting onwards. Is it fine? Any doubts? We'll go to the next one.
Yes,
Yes,
sir.
sir.
So this last problem will do for this class. Okay. So here we are having x cube d cube y by dx cube plus 3x square d square y by dx square plus x into dy by dx plus 8y is equal to 65 cos of log x. Now here the substitutions we have to make is x cube d cube y by dx cube is equal to, what is it, d into d minus 1 into d minus 2. So that means 3 minus 1 we have to take. So 2. 3 minus 1 is 2. Up to 2 we have to stop. Into y. Similarly, x square d square y by dx square is equal to d into d minus 1 into y. Similarly, x into dy by dx is there. So this is dy. So total 3 terms having derivatives. I have substituted 3 substitutions here. Next, here t is equal to log x implies x is equal to e power t. So this is for variable substitution and this is for derivative substitution. Now substitute in it, what happens? So take it as equation 1. From equation 1, so d into d minus 1 into d minus 2. Next, plus 3 into d minus 1 plus d plus 8 into y equal to 65 cos log x can be written as t. So cos t, 65 cos t will get. So therefore multiply in the left hand side, that means simplify in the left hand side, d into d minus 1 into d minus 2. So that means d square minus 2d minus d. So you'll get minus 3d minus 1 into 2, you'll get plus 2 plus 3 into d into d, you'll get 3d square minus 3d into 1, you'll get 3d plus d plus 8 is equal to 65 cos t. Still multiplication is remain. So we'll get d cube minus 3d square plus 2d plus 3d square minus 3d. So minus 3d plus d. So I'll get minus 2d plus 8 into y equal to 65 cos t. So 3d square minus 3d square get cancelled. 2d minus 2d get cancelled. We got d cube plus 8 into y is equal to 65 cos t. Now this type of problems also we have did in type 2. Okay, this is related to type 2 equation. So how to do this? First we'll find complementary solution, that means auxiliary equation is m cube plus 8 equal to 0. So first we need to do synthetic division for this because it is a cubic equation. So m cube quotient is 1, m square quotient 0, m quotient 0, constant is 8, here 0. What will be the initial solution?
-2.
So you have to write minus 2, add it 1, minus 2, 0, sorry, minus 2 into minus 2 will get plus 4, add it 4, minus 8, add it 0. So implies m1 is equal to 1. Similarly, m1 is equal to minus 2. Next, m square minus 2m plus 4 equal to 0. Implies m is equal to how much? 2 plus or minus root of 4 minus 16 divided by 2a. So that means 2. M is equal to 2 plus or minus root minus 12 divided by 2. So 2 plus or minus here 2 root 3 I. So root 12 can be written as 2 root 3 divided by 2 m is equal to 1 plus or minus root 3 I. Fine. So therefore, yc will be how much?
C1 e raised to minus 2t.
Okay. C1 e power minus 2t.
E raised to t into
Yes.
C2 cos root 3t plus
Yes.
C3 sin root 3t.
Okay. So therefore, yc is equal to, you can replace with x. So C1 e power t whole power minus 2. So that means x power minus 2 you can write. Plus e power t can be written as x into C2 cos root 3 t can be written as log x plus C3 sin root 3 log x. Okay, so this is yc. So therefore yp is equal to how much? 65 cos t divided by dq plus 8. Okay, so yp is equal to 65 cos t divided by, here this can be written as divided by d square into d plus 8. So here d square can be replaced with minus 1, correct, because t quotient is 1. So d square must be replaced with minus 1 square. So minus 1 square is minus 1. Okay, so we'll get minus d plus 8. Now again denominator is in terms of d. Convert into d square by multiplying conjugate of it. So minus d minus 8 divided by minus d minus 8. So yp is equal to, so multiply for the first term, minus 65 d of cos t minus 8 into 65. So I can write it as directly 8 into 65 cos t divided by d square minus 8. 8 square, that means 64. Minus d square is d square, minus 8 square is 64. Yp is equal to differentiation of cos t.
minus sin t.
So we'll get minus sin t. So minus of minus will get plus 65 sin t. Okay. So minus 8 into 65 cos t divided by d square must be replaced with minus 1. So minus 1 minus 64. Okay. So yp is equal to, if you take minus 65 common, what happens? 8 cos t minus sin t divided by, in denominator also will get minus 65. So minus 65 minus 65 get cancelled. Yp is equal to 8 cos t minus sin t. What? So yp is equal to 8 cos log x minus sin log x. So write general solution for this. y is equal to yc plus yp, which is nothing but, therefore y is equal to yc. Yc is, it is a quite big solution, c1 x power minus 2, okay, plus c2 cos root 3 log x plus c3 sin root 3 log x into e power t means x plus yp. Yp is 8 cos log x minus sin log x. So this will be the general solution.